Good morning, everyone. Today we are going to dive into a fascinating and essential topic for mastering physics: differentiation. You may be in class 11 or class 12, you might have maths or you don't have maths. Understanding differentiation is like unlocking a powerful tool that allows us to describe and predict the behavior of physical systems with precision. What is differentiation? Why am I so energetic to tell you all these things? At its core, differentiation is a mathematical process that helps us understand how things change. It's about finding the rate at which quantity changes with respect to another. In physics, chemistry also, some chapters, this concept is crucial because the universe is in constant motion and change. Whether it's speed of car, the acceleration of a rocket, or the flow of electricity, differentiation helps us quantify these changes. Why is differentiation important in physics? Number one, describing motion, velocity, and acceleration. Differentiation allows us to derive velocity from the position of an object over time and acceleration from its velocity. Number two, equations of motion. You class 11 students struggling with the derivation of equations of motion. After this session and the following session, I hope you don't have any problem. What is the use in equation of motion? It forms the backbone of equations of motion in kinematics and dynamics. Without differentiation, you cannot think even. Number three, understanding forces. Newton's laws. It helps us apply Newton's laws of motion, particularly in analyzing forces and predicting future motion of objects. Number four, electromagnetism. Maxwell, the genius, who used differentiation to derive his equations. Those are Maxwell's equations, which describe how electric and magnetic field propagate and interact. Number five, wave motion, wave equation. You all know wave. You may be you may have attended just a few classes of class 11. Wave equations, wave, sound wave, light wave, they travel in air, in vacuum. Differentiation helps in studying the properties of waves such as amplitude, frequency, and wavelength. Some real world examples also there. Car dynamics. When you are driving, your speedometer measures the rate of change of your position, that is your velocity. Your car's acceleration is the rate of change of this velocity. Projectile motion, which you have studied or going to study. When you throw a ball, its trajectory can be analyzed by understanding how its velocity changes over time due to gravity. Then, how to visualize differentiation? When you consider the graph of position versus time, you all have the experience because you have passed class 9, 10 level. Imagine the graph of position versus time for a moving car. The slope of this graph at any point gives the car velocity. If the slope changes, it indicates acceleration or deceleration. Differentiation allows us to calculate these slopes precisely. By the end of today's session, you will see how differentiation is not just a mathematical concept, but a practical tool that we use to describe and predict the physical world around us. We'll explore various examples and solve problems together. making sure you gain a strong grasp of how to apply differentiation in different areas of physics. Without wasting time, let us start. So, we'll sometimes apply some trigo formula also, but we cannot do all the mathematical topic in one class which you require for physics. Let us start with the concept of differentiation, which is very useful. We need to learn it properly. Okay?
Yes.
In mathematics, this quantity delta x, in physics also, we'll be using this. Delta x stands for change of x. This is equal to x2 minus x1. So what is the meaning of delta x? It is change in x. I did not say that it is small change in x. It is just change in x. One can write this change as some final value xf minus xi, x suffix f. So I hope you are practicing with me. Your pen and paper also ready
Yes,
with
sir.
ready for
Yes.
this class. Huh?
Yes.
Whatever I am doing here, you do it with me.
Yes.
Learn it with me, and
Yes.
then apply in problem. You will get enough time to solve a problem. There, right now, just learn. So delta x is x final. I mean final value minus initial value.
Yes.
You have to remember that this we are doing, this mathematical topic we are doing here for the sake of physics. We are not going to learn in details all the mathematical concepts. Then it will be math class. This won't be a physics
Yes.
class. So we'll just know the technique, how to differentiate, how to apply it in physics. Clear?
Yes.
So delta x stands for change in x. If somebody says that, then what is delta y? Okay, same thing. Delta y change of y, that is yf minus yi.
Yes.
This is also change of y. Delta t is what? Delta t stands for change in time. Okay? Delta
Yes.
t stands for change in time. Average velocity, all must have done that. Average velocity, v average is equal to change of position, change of displacement. Better to say change of, I mean displacement. Displacement is what? Final position minus initial position. I mean change of displacement by change of time. Change of displacement may not be the appropriate language. It is just final position minus initial position. Just to bring the concept of delta, I am writing this. Change of displacement by change of time. So one can write by using this symbol. If you just learn V average equal to delta x by delta t.
Yes.
You might have seen that authors are writing this manner: V average equal to delta s by delta t. No issue. You can write any symbol. It is just displacement by time.
Yes.
Just to indicate it has change, I've written change of displacement by change of time. Okay.
Yes.
Now, when this delta t is very small, when delta t is very small, we use this mathematical symbol delta t tending to 0. I mean, when delta t approaching 0, this V average We'll write this manner. Limit delta t tending to 0, delta x by delta t. Okay? So this is just delta t tending to 0. You don't have to, this is actually concept from limit. We cannot learn whole of limit. We just remember that it is delta t tending to 0. I mean, very small quantity in mathematics. And in that case, this is going to be dx by dt. Clear?
Yes.
So V average is delta t tending to 0, delta x by delta t, or dx by dt. This is the application of the concept in physics. What is the concept then? Initially it was average. Now it has become instantaneous. This thing is average. This thing is instantaneous. This is called instantaneous velocity. Okay? I'll not be
Yes.
doing instantaneous velocity now. Definitely we'll do lots of sums based on it. Just I tell you why the concept is required in physics and why we'll apply this mathematical tool. Just a minute. Just suppose there is a particle describing two-dimensional motion going like this. Okay?
Yes.
This curvilinear motion is possible. This
Yes.
x and t, this kind of motion is possible. So every point, the change of displacement by change of time, that factor is changing. And that change is not uniform. We cannot use this formula to find average velocity. This formula you can use when there is a problem like this. You must have seen this displacement time graph is or x this manner, time this manner. The graph is like this. In this case, it is average or it is uniform. It is not going to change. We can get it by this thing only. Delta x by delta t. Suppose at any instant time it's t1, displacement is x1. Another time t2, displacement be x2. Clear? This is
Yes.
x2. This part is x2. This part is x1. So what about this change of time? Delta t is going to be what? Delta t equal to t2 minus t1. Because this time is delta t. And delta x is what? This whole thing is x2. You can see that. This part x1. So this part is delta x. That is x2 minus x1. Delta t is what? T2 minus T1. Now, average velocity delta x by delta t is going to be what? It is perpendicular by base. This is called tangent of the angle, tan theta, isn't it? This is
Yes.
called slope of the line. I'll tell you all these things in details one by one, but okay, that I'll talk. This is slope of the line. Then slope of the line means what? Tangent of the angle it makes with the time axis. This is theta means this is also theta. Slope of the line delta x by delta t tan theta, that is equal to average velocity over there. Okay? You might have seen it in junior classes 8, 9, 10. If you haven't seen, okay, don't worry. We're doing it. Just I wanted to tell you why calculus required for 11 plus in CBSE or other board, whatever you require. So here it is tan theta delta x by delta t. It is slope, and this is called average velocity. You can remember this concept also, that in XT graph, average velocity is equal to slope of XT graph. Okay, just try to remember this. We'll be doing in details again in maths class with maths teacher also. You'll be doing. Don't worry. So just remember, in XT graph, average velocity is slope of the graph. Problem arises when the graph is not a straight line. This calculation of slope is very difficult. Delta x by delta t you won't get easily. Then what you will do? In that case, you need to find that you cannot see that at the point velocity, at this point v velocity is same. No, it is changing. It is changing both magnitude and direction. Here, if the point
Yes.
A is there, the point B is there, velocity at A equal to velocity at B. But particle moving in curvilinear path is not the same. Got it?
Yes.
So that quantity going to be changed in case of curved path. We need calculus because of that. Instantaneous velocity, instantaneous acceleration, all these things we need because of this. When change is not uniform, we need calculus. You know, calculus invented by famous, I don't know whether you will say him, physicist or mathematician, Newton. It was invented by him. Leibniz also there. He invented at the same time, the same period, both of them. They used to know mathematics, physics, they are great people. We know now nothing. Now it is a fraction of knowledge we have, what they acquired. Okay. So average, why calculus now you have understood? If the motion
Yes.
is not, I mean, dispersion time graph is not in straight line, we need calculus. We need instantaneous velocity, instantaneous acceleration concept. But today's class will be telling you definitely how to get it. But before that, you learn how to find the instantaneous velocity, that is derivative of something. This is called derivative of function.
Yes.
This x is a function of time. Displacement of a particle may be along straight line, but with time it is changing. Am I right?
Yes.
A, B, C. This is the origin. Say from here it started going at these positions. Displacement changing. Now, this position, if we take as origin, and this distance is x1 from origin, this is x2, this is x3, then displacement in going from B to C is x2 minus x1, that is delta x for this interval. From C to D, delta x is there, that is x3 minus x2. It's like that. Now, this change over time we are going to calculate by using calculus, and we will say that this displacement, these are different values of x at different time. We write x is a function of time. This symbol is new for you. You might have done before, but this is concept of function. Two variables, x and t, they are called variable. These are called variables. Okay. So function, displacement is a function of time. Acceleration is function of time. Somebody can write acceleration equal to gt, some other function. Acceleration is a function of time t. This is the concept of function. When you're writing that velocity time graph, that you are writing v equal to u plus at. Here v is a function of t. Remember this. Okay. Here v is a function of t. Here displacement is a function of t. I give you the formal definition now. You'll understand better. So what is definition of function I am writing? Mathematics, when you're doing class 11 mathematics, you will get a definition that is perfect. There is no fallacy of it. What I'll tell you today, it has no contradiction with that, but this will be more useful to understand physics. Okay? So I'm not using the definition you got in class 11 mathematics. I'm using the definition you need for physics. Function. What is function? If two variables x and y are related in such a way that to every change in x there is a change in y also, then y is said to be a function of x. Two variables x and y are related in such a way that to every change in x there is a change in y also, then y is said to be a function of x. We write y equal to fx. The way we have written x equal to ft. X is a function of time. Okay?
Yes.
Here x is the independent variable and y is the dependent one. Dependent on what? Dependent on independent variable.
Yes.
So x is a function of t. It means time is dependent. Time is independent variable. X depend on time. Displacement changes with time. So x is a function of time. We write x equal to ft. Okay.
Yes.
Now you just consider the change of this function on a interval. Number line concept, you know. Number line means
Yes.
whole of x-axis is called number line. On the
Yes.
number line, suppose there are 2 points. One is x and the other is x plus delta x. Don't be confused. On the number line, there may be point 1, there may be point 6. If this is your x, this is x plus delta x. So x is the value of the variable. Which variable? The independent variable at A. At B, it has value x plus delta x. Like this. X has value 1 here and value 6 there. Just a small, just a change is there. That's it. X plus delta x. Now, What is the value of function at this point, at x? Function is fx. What is the value of function at this point? It is x plus delta x. Clear?
Yes.
That is fx, and this is x plus f of x plus delta x. You can say that, why not y? Why you are not writing y? Yes, y is fx, we can write. Then what to write for this? Y is also changing. I write y plus delta y. Okay? Y equal to
Yes.
fx is the function. Functional value change, it has become y plus delta y. When the point is x plus delta x. Now, change in x I'm writing here. Change in y I'm writing here. Change in x, we have taken delta x. So, when variable changes by delta x, that variable, change in variable, change in x, delta x, change in y is delta y. Change in x is 1 by unitary method, this will be delta y by delta x. Isn't it?
Yes.
This is average change in y. Like average velocity, this is average change in y. This is in mathematics, and this is in physics. Del dx by dt, delta x by delta t. This is in mathematics. There is no contradiction. Here we are denoting it by variable. There all those physical quantities are there. Change in x delta x, here delta y, 1 delta y by delta x. This is average change in, this you refer as average change in y. Okay?
Yes.
It's called average change in y. Now, when delta x tending to 0, the ratio. What ratio? Limit delta y by delta x. This is called dy by dx. This was average. But when delta x tending to 0, that average will be changing to instantaneous. Okay? This
Yes.
is called instantaneous. Or we say that this is derivative of y with respect to x. This is called derivative of y with respect. This instantaneous change is called derivative of y with respect to x. Somebody has calculated derivative this manner, then this process is called, the process is referred as the process is known as differentiation. Okay?
Yes.
The result you got, the value of dy by dx, the value of dy by dx is known as the differential coefficient of y. So what result you got? The result of dy by dx. There is definitely calculation. You get a value 1, 2, 3, 1 by 2, 1 by 3, whatever, 1 by x. That is called what? That is called differential coefficient of y. Dy by dx, derivative of y with respect to x. The result you got, that is called, process is differentiation. The result you got is called differential coefficient. Hope this is clear to you.
Yes.
Average Instantaneous, all this there in mathematics. From mathematics, we are borrowing the concept in physics. It has become average velocity or average acceleration, instantaneous velocity or instantaneous acceleration. All these things. Clear?
Yes.
Now, how to find this dy by dx for elementary functions? What are those elementary functions? Let me tell you. You must be trained by your mathematics teacher also about elementary function, but as a teacher of physics, I have to tell you that also. Okay, I will remind you that. We learn differentiation of elementary function, then differentiation of composite function. Okay,
Yes.
then we'll go for finding derivative in complicated case and applied physics. Okay, let us know the. Acha, another thing I'd like to say, this dy by dx when you got, just make an observation here. What you got? This dy by dx is what actually this thing. Let me take one very interesting result, very important result. Okay,
Yes.
dy by dx, we have got limit delta y by delta x. So this thing we can rewrite as y plus delta y minus y by delta x. I'm adding just y and subtracting in the denominator. Clear? dy by
Yes.
dx is this. The delta y we rewrite y plus delta y minus y. This you write y plus delta y is what? We have done it before. It is f of same thing. And y is fx. That divided by delta x. So dy by dx will be getting by this formula. At least a few. Then we learn the formula only. No derivation.
Yes.
Sometimes in physics theory problem, theory question paper, in your school or board examination, they used to ask this manner. Using first principle in physics paper, you are seeing that using first principle, find the derivative of this, like that. Okay.
Yes.
So first principle you have to learn in physics. You have to know it, and it's very interesting because of its application. Okay.
Yes.
So let us apply it, and this derivative formula what you got here, this is called differentiation by first principle. Okay, this is
Yes.
called differentiation by first principle.
Yes.
No second principle at present. No second principle in future also. Only first principle.
Okay.
Okay. So
Yes.
first principle, let us apply to find derivative for some problem. Then we'll go for formula. Then derivative learn. So let us find by first principle. By first principle, find the derivative of. I'm giving some elementary function. Elementary function in details I'll tell you later. Right now, this is a polynomial function x square. You do. Then you do 1 by x. Then you do it for a constant c. By first principle, find the derivative. And one sum I'll give you as homework. If you say that now I'll do it here, it's up to you. X minus 1 by x plus 1. See, I used to teach in a school like Delhi Public School, Ruby Park, as a teacher of physics and mathematics. I used to run both the department. Okay. There, I set this question in physics paper that using first principle. I'm just sharing school experience first. Using first principle, find the derivative of x minus 1 by x plus 1. Maybe teachers are changed, but question is not changed. Okay, so you learn it with me. Let us find the derivative of x squared first. Answer. So you write here the function is fx equal to x squared. Here fx is x squared. We are solving number 1. Now we write the definition. I remind you the definition. We write dy by dx. This is another name. First principle differentiation. We can write this as symbolically f dash x also. People say that no, you are wrong. You are saying dy by dx. You don't know mathematics. We mathematics people never say dy by dx. It is an operation. It is ddx of y. Rate of change of y. Why are you referring dy by dx? You are using layman's language. I do it for students. Dy by dx. Rate of change of y with respect to x. I often say that it is for students. But actual meaning is this is not an algebraic thing. You are not dividing anything by anything. You are finding what? Rate of change of what? Rate of change of y with respect to x, d dx of y. Clear?
Yes.
So for this function, y is this? Fx or x squared. And this was by definition limit h tending to 0. Sorry, not h. I did not take h, I took delta x. Delta x tending to 0. People sometimes take it as h also, no problem. Delta x tending to 0, f of x plus delta x minus fx by delta x. I'm going to apply this for this sum. So f of x plus delta x will be changing x only.
Yes.
X plus delta x whole square. So is this definition. Now dy by dx will write limit f of x plus delta x is x plus delta x whole square just no simple applications. Okay, we are not doing it for the sake of mathematics, doing it for physics. So x square getting cancelled.
Yes.
When x square getting cancelled, then this is becoming these to get cancelled. It is tending to 0, no, not exactly 0. So you can cancel from numerator and denominator. Okay, another thing is there. Wait a minute. Let me write in details this part. You take delta x common here. Cancel these two as this is tending to 0. So in that case, you put delta x 0 here, it is 2x. It is tending to 2x. So rate of change of x square, I have got 2x by using first principle. You know it. There is no harm in learning a topic which will give you detailed idea, which will help you to understand concept afterwards. But result we need mainly for physics, rate of change of x square is 2x. So if your displacement time graph has a function like this, their rate of change of displacement, that velocity will be given by this form. Okay. So x square derivative, I hope you have understood. ddx
Yes.
of x square equal to 2x. Let me do it for 1 by x. fx equal to 1 by x. So this is going to be 1 by x plus delta x.
Yes.
So dy by dx will be this is by definition. Now we'll put all these things. But we got that f of x plus delta x we write in details, and this divided by delta x. Take the LCM. Minus delta x by delta x get cancelled. So limiting value you are calculating, at the end you can put x plus 0. This is going to be minus 1 by x squared. Therefore, rate of change of 1 by x is minus 1 by x squared. Clear?
Yes.
This is derivative of 1 by x. Think about derivative of constant. Fx equal to 3. The meaning of constant is required for that. Meaning of constant means it is invariant quantity. Its value never changes.
Yes.
So if we are going to do it for constant one, number 3, you have to say fxk, f of x plus delta x, that is also k. So dy by dx will be limit clear.
Yes.
Same definition I am using. So what it is going to be? Just a few. This is 0. This has become 0. So derivative of constant function is equal to 0. You have nothing to do. Derivative of constant is 0. Okay?
Yes.
It's not a maths class. This is physics class.
Yes.
Now we are going to remember the formula only. But formula has some basis. Where does it come from? Why should I learn? Is it valid what I am learning? That will be clear now. Calculus formula you will definitely use, but why you will use? The answer you got. Formula I have derived already. I'm showing you what way I have derived. What way I have derived. I'm just showing you. I have found the value of x squared derivative. I have found 1 by x minus 1 by x squared. Let us make the observation here. I'll get a pattern and then the purpose is solved. We found d dx of x squared equal to 2x, which is nothing but 2x to the power 2 minus 1.
Yes.
I have found d dx of 1 by x. It is d dx of x to the power minus 1. What result have I got? Minus 1 by x square, you are writing minus 1 minus 1. You see something? For x square, it was 2x to the power 2 minus 1. For 1 by x, it is x to the power minus 1, it is minus 1 outside x to the power minus 1 minus 1. If you have found ddx of x cube, you must practice. You all must practice here. It will become 3x square. This can be written as what? 3x to the power 3 minus 1. Can I see something? The index was 3. 3 has come here. Then here, index will be reduced by 1. Similar is the case for all. So, if you tell me the formula, can't I write this thing? ddx of x to the power n equal to nx to the power minus 1? Of course.
Yes.
So, derivative of x to the power n. You forget everything, but don't forget this one. This formula
Yes.
will apply in physics. But how does it come? I have to tell you, that's why I took 3 examples. And now I'll give you formula list. If you derive all those by using the first principle formula, what formula you will get, that I'm going to write. Okay? Step by step. So formula for differentiation. Formula for differentiation. I write the function in the first row. Then I write its derivative. Number 1, just we have learned here. Derivative of, no, we write function only. Don't write derivative here. You just write the function. Function is y equal to x to the power n. Derivative dy by dx. I showed you how it is n x to the power n minus 1. Then derivative of constant, y equal to k. K is a constant. What have I got? Dy by dx equal to 0. Okay? These are formula. This you are going to apply in future. Then the fourth one. Fourth one is y equal to sine x. Okay, sine x. Okay, sine x. You copy trigonometry. If you do it by first principle, its derivative going to be cos x. Okay. We are going to do for next one, that is cos x. If you derive, don't derive. In physics, never derive. Dy by dx will be, but the question can give you, I gave you that x plus 1 by x minus 1 or something like that. That is important. So dy by dx is minus sine x. And then for tan x, by first principle ddx of tan x, you can write this also, equal to sec square x. That is ddx of tan x. Then we'll do it for y equal to cot x. This will be minus cosec square x sec x sec x tan x. Ddx of sec x will be sec x into tan x. And then there is number 9, y equal to log x. Dx of log x will be 1 by x. Then we write y equal to a to the power x. Dy by dx, a to the power x. It will be a to the power x log a base e. This is another topic. Log, you need to learn it your mathematics teacher in details. Here
Yes.
I'll tell you, but for the sake of physics. Log you need to learn in mathematics. Log may not be there, but you have to learn it. It is very important tool for all class 11 and 12 chapter. Log x you must learn properly. If you seek my help, then okay. Definitely I. So y equal to a to the power x we got, log x we got.
Yes.
All these elementary functions will be applying by for differentiation by knowing the rules of differentiation. Let us know the rules of differentiation now. All these formula required one by one. Let fx and gx be two functions of x. Fx and gx be two functions fx and gx be two functions of x. There may be one sin x, one cos x. There may be one x cube, one 5x, like that. The rule of differentiation states that if you find derivative of their sum, it will be derivative of first plus derivative of second. If there is a minus sign, there will be a minus sign. All right?
Yes.
Dx of k into fx, that constant will come outside. It will be d dx of fx.
Yes.
There may be product of two functions. Fx into gx. There it will be fx derivative of gx plus gx into derivative of fx. All right? This is
Yes.
called product rule of differentiation. And the last one, that is called quotient rule. This will differ as product rule. This is sum or difference rule, product rule, and there is quotient rule. What is that? gx whole square, gx into derivative of fx, fx into derivative of gx. Look at the third and fourth. Just look at third and fourth. Try to understand. I'll give you lots of examples. Don't worry. Everything will be done. Just check number 3 and 4. Did you understand?
Yes, sir.
Okay. So third one is product rule and second one is quotient rule. Let me apply in solving sums there. This product rule, I'm keeping it side. Otherwise, I have to scroll again and again. So I am going to find ddx of, say, just question given this manner. Find dy by dx when number 1 y equal to x cube plus sin x, y equal to number 3 x cube cos x, number 1 y equal to, say I am taking x4 by log x. Let me do these 4 sums. Then I'll give you a set of 4 problems.
Yes.
But later. You try to understand this. Keep the formula ready with you. Formula always in my mind.
Yes.
Okay?
Yes.
See how to use the concept you have got, how to differentiate this function. The first one, answering 1. You have to think which rule you are going to apply. That is sum rule, fx plus gx. But you give a statement, differentiating with respect to x. We are going to differentiate with respect to x. Left hand side will be dy by dx. Nothing else to write that. Right hand side will be ddx of x cube plus sin x. Clear?
Yes.
So this is nothing but ddx of x cube plus ddx of sin x.
Yes.
This part is 3x square. You know, by formula, x to the power n, nx to the power n minus 1. So its derivative is 3x to the power 3 minus 1. 3x square plus cos x. Clear?
Yes, clear.
Let us do it for number 2. Number 2 I'm doing here. So one thing, that sum rule is valid for more than 2 functions. Instead of fx dx, there is another hx also. Then it will be derivative of fx plus derivative of hx plus derivative of hx. So we are going to apply it there in this sum. Y equal to so you write dy by dx will be ddx of, okay?
Yes.
This is d dx of, they are splitting. Sum of first plus second plus third. d dx of first, d dx of second. Clear? d dx
Yes.
of 7. So this one, when you write 3 comes outside, d dx of x, constant derivative is 0. X squared derivative will be 2x. X derivative will be 1. Why? Why? Because the formula we got, d dx of x to the power n, x to the power n minus 1. That's why. For 1, what did you write? It is 1 x to the power 1 minus 1. There is
Yes.
1 into x to the power 0, that is 1. So answer is 6x minus 6. Clear?
Yes, sir. Clear.
Let's go for next one. Like number 3. Y equal to x cube cos 6. We'll be using product rule. What is the rule? That derivative of fx into gx, fx into derivative of gx plus gx into derivative of fx. So you write again the same statement. Differentiating with respect to x, x cube cos x. Okay.
Yes.
So this is what the rule is: first into derivative of second,
Yes.
x cube derivative of cos x plus cos x into derivative of x cube. So it is x cube minus sin x so x square you take common, 3 cos x minus x sin x. Done. It's just simply using formula. Rules you keep ready with you. I'll give you a set of problem. Otherwise, just use your formula. Nothing else. Let us do it for this sum. I've given another one to you. That was x4 by log x. You're going to do that. You're going to do number 4. Y equal to x4 by log x. So this quotient rule states what? In the numerator, this into derivative of numerator minus this into derivative of numerator. So write again differentiating with respect to x, log x whole square clear.
Yes.
So what is the derivative of x to the power 4? Derivative of x to the power 4 is 4x cube. Log x derivative 1 by x. Value is log x whole square. You simplify or not, it doesn't matter for this moment. It is done. Clear?
Yes.
So differentiation, how to differentiate a function, I hope it is clear to you. You
Yes.
apply the concept on 4 simple problems. Just writing one by one. Find dy by dx y equal to x to the power 30, y equal to 1 by x to the power 4, y equal to x4 minus 6x cube plus 7x minus 9, and then y equal to, just practice some, maybe very simple problem, but need to do. And then y equal to cot x by log x. These 5 sums you'll be doing. Okay, just do
Yes.
practice.